Second chapter in module 4, that is instance based learning, is learning set of rules. So in learning set of rules, first we'll see the introduction part. In the introduction part, we are going to see about the definition of a learning rule or a learning process. Next, we have the different rules, that is a classification, two types of a classification in a learning set of rules. So first see the definition of a learning rule or a learning process. The learning rule or a learning process, it is a method of a mathematical logic or an algorithm which improves the network performance or a training time. Here, in order to improve the network performance or a training time, so we are going to use a set of rules. That is, when we convert, so here we are going to convert the logical relationship into a set of rules. Suppose if we consider the decision tree, we know that a decision tree, it is a pictorial representation where each and every based upon the condition, we are going to perform the classification. So based upon the Boolean function, that is yes or no. So it is a binary related classification, that is which classifies based on 0 or 1 condition, that is yes or no condition. Now suppose if decision tree, it is converted, that is a logical relation decision tree, example I am giving, it is converted into a set of rules, then there will be a proper utilization of a network performance and the training time. So this is known as a learning rule or learning process. So once again I'll repeat, the learning rule or a learning process, it is a method in which the mathematical logic or an algorithm, it is going to improve the network performance or the training time. So here we are going to convert, that is a logical relationships are converted into a set of rules. So this is known as a learning set of rules. So next we'll see the classification of a learning set of rules. So before that, let's understand why we need a learning set of rules. So we know that in a machine learning system, it is a rule-based system. It helps in the identification and utilization of a set of relational rules that correctively represent the knowledge captured by the system. Now, this learning rules, if we utilize it instead of a lengthier decision tree and given to a code in the form of a rule, then there will be a proper utilization of a set of relational rules, and thus reduces the time and also improves the performance. So this is known as a learning rule. So now let's understand the classification. Here we have two types of a classification. In the first type of a classification, we have two types. One is a decision rule or an if-then rule. So in a decision rule or an if-then rule, first we are going to consider a decision tree. The machine is going to understand or learn the decision tree, then it translates the decision tree into a set of rules. That is an if-then rule. Means it is same as that of an if-else condition. So if condition is satisfied, then certain statements are going to be executed, or else then condition is executed and certain set of statements of then condition will be executed. So that is an if-then rule or a decision tree rule. Understand, in a decision rule or an if-then rule is the one where the machine is going to consider the decision tree and then it translates the decision tree into a set of an if-then rules. Example, you can take any decision tree and write it. Next, genetic algorithm. The genetic algorithm, as the name itself indicates, it is based upon the, if I compare the analogy, you know that in a biological terms, what does a genetic means? So here, in a genetic algorithm, in a machine learning, the rule is represented in the form of a bit string. So bit string in the sense in the form of ones and zeros, and uses a genetic search operator to explore this hypothesis space. I hope you know what is meant by hypothesis space, and hypothesis space is the one where you have all the predicted values or predicted prediction. So when you compare the predicted value to an actual value, if it is correct, then we say that the error is less and we say that the prediction is accurate. So hypothesis space is the one, it is a collection of many such hypotheses. Now genetic algorithm is the one where the rules are represented in the form of a bit string, that is zeros and ones, and you're going to use a genetic search operator to explore this hypothesis. The search operator here, it performs in 3 steps. First is the selection, second is a crossover, next you have the mutation. So selection, what is meant by selection? Selection here, suppose you have a many number of a bit stream. So in a selection process, you're going to select a 2 or more best parents from a population in order to perform the crossover. So selection process is nothing but selecting the best parents. So you have a procedure for it and you have a problems for those. So all those things are not there in your syllabus. Just understand the definition, that is sufficient. Next step is crossover. A crossover is randomly cutting the bit stream. The randomly cutting the bit stream, in the sense it can be in an LSB part or in an MSB part. And the randomly cut bit stream, it is chosen by the user depending upon his need. He can perform an LSB cut or an MSB cut. So this randomly cutted bit stream, it is then swapped and then it is concatenated. This is known as a crossover process. The next step is mutation. After performing a crossover of 2 parents, we are going to get the child string. So this child string is considered and the mutation is performed, that is changing 1 to 0 and 0 to 1, and randomly selected string it is being performed. Note that we are going to choose here randomly selected string. There is no rule that which bits you have to consider. So you can choose any of the bits depending upon the need of the user. So this is known as genetic algorithm. So the first classification, you have 2 types. One is a decision rule or a if-then rule. So here in a decision rule, the machine is going to learn the decision tree and then it is going to translate the decision tree in the form of an if-then rule. And a genetic algorithm is the one where each rule is represented in the form of a bit string in the sense in the form of ones and zeros, and using an genetic search operator. So you're going to explore the best hypothesis space. So genetic algorithm, it is performed in 3 steps. One is an selection, next is a crossover, next is a mutation. Now let's see the second type of a classification. The second type of a classification, you have the first order rules. The first order rules, it is also called as in Horn classes. So here you can consider the example. So let's understand what is meant by a first order rules. The first order rules are defined by consisting of an variables. Here x and y are considered as a variables. Without knowing the variable value, here we are going to define the rules. So that is known as a first order rules or an Horn classes. So let's consider the example. If parent x comma y. So here how you have to read is y is the parent of x. In the sense y can be a father or mother of x. If y is the parent of x, then y is chosen to be as an ancestor of x. Now let's see the second example. If parent x comma z, in the sense z is the parent of x, correct? Z is a parent of x. Next, what does this symbol indicate? It indicates the conjunction. Conjunction means what? Conjunction means it is an AND function. So how does that AND function work? When both the condition are 1, then the result is going to be true, right? So this 2 conditions, it should be satisfied. So let's see. One condition means your AND operation. How the AND operation is performing? 1 into 1, then only you are going to get 1. Suppose it is 1 into 0, 0 into 1, this is not going to work, right? So let's see this condition. If z is, we know that z is the parent of x and y is the ancestor of z, then if both the conditions are true, then you can say that as y is the ancestor of x. Understand? Who is z? Z is the father or mother of x. Z is the father or mother of x, and y is considered to be as an ancestor of z. Okay. Who is z now? Z is a parent of x. Then can I say it as y is the ancestor of X? Yes, I can say it. Since this is an AND condition, it is going to be true. Understand? This Z is the parent of X, where Y is the ancestor, that is grandfather or grandmother of Z. Now can I write as my Y is the grandfather or grandmother of X, when Z is the mother or father of X and my Y is the grandfather or grandmother of Z, can I write automatically that Y is also the grandfather or grandmother of X? That is only I have written here. So this is known as a first order rules, where you are going to operate in terms of a conjunction and you are going to operate it on the variables. Next, second type of a classification here, it is a propositional rules. In a propositional rules, instead of considering the variables, you are going to consider the values of the variables and you are going to perform the rules. Here, understand, whereas in first order rules you have considered the variables, whereas in a propositional rule we are going to consider the values of the variables. So what are all the classification I have written here? All the classification, it is based on an sequential covering algorithm. So now what is the sequential covering algorithm? As the name itself indicates, sequential means it is one after the another. So all the algorithm here, it is going to work in the form of sequential, means it is going to consider only one training example from the database. It is going to formulate a rule and delete that complete training example. In a sense, if you have a complete database and if you are considering the first row of that database, that first row is considered, rules are being formulated, different rules are being formulated, any rule, any method you can apply it, and then that when it moves to the second row, the first row will be removed. So this is known as sequential covering algorithm. So the sequential covering algorithm is the one, it learns one rule at a time and then incrementally grow to the final set of rules. So this is known as sequential covering algorithm. So what are all the classification? That is a decision rule, genetic algorithm, first order, propositional rule. All these rules are based on sequential covering algorithm. So I hope you understood. The question they can ask from this is, define a learning rule and explain the classification of a learning rule. So much you have to explain it. So you have to define the learning rule. You have to explain two sets of classification. In the first set you have decision rule and a genetic algorithm. In the second set you have first order or an Horn classes and a propositional rule.